The general rule for doing math with significant figures is that math cannot change precision. Okay, so taking an imprecise number and multiplying it by a precise number does not make your result more precise. We have to maintain precision as we go through our calculations. So the rule for addition and subtraction is we keep to the least precise. So let's take a look at this. For these two measurements here, 7.054 and 1.22, we're going to add them together. I am only allowed to keep to this place right here, 2 places past the decimal. This number is precise to 3 places past the decimal. This number is precise to 2 places past the decimal. My answer can be no more precise than 2 places past the decimal. So when I put this in my calculator, or just do it because it's not that hard, this is what I would get. No question I did the math right. However, I need to represent this as a number that just is precise to 2 places past the decimal, which means that this would be 8.27 centimeters. Okay? For this one right here, again, I've got 2 significant figures in this number, 5 in this one, and I'm precise to 3 places past the decimal right here. So that's all I'm allowed to keep to. So 6, 6, 6, 3.2, that's what I'm allowed to keep to, and I'm only allowed to have 3 places past the decimal, so this 6 right here will end up rounding this one up. So I would represent this number as 2.367 in its grams. Okay, so this is precise to 3 places past the decimal, just like this number is. It does not matter that I have 2 sig figs here and 5 here. I'm allowed to end with 4. Okay, so this is a number of significant figures that is not in either of the things that went in here, but it is precise to the right place past the decimal, 3 places past. Okay, for this one, just so you don't see me stumble through math, I will use my calculator. So for the subtraction here, 4050 minus 193, 3857 is what my calculator gives me. Okay, but this number is precise to the tens place. This number is precise to the ones place. I cannot be any more precise than my least precise number, so I'm only allowed to keep to this place, which means that this number, 3857, would round to 3860 kilometers. Okay, so again, I'm precise to the tens place, just like my least precise measurement. This one right here, a little weird way of looking at it, but not so bad. So 1.040 times 10 to the second minus 87. And I end up getting 17. All right. One way to think about this is that my number is actually 104.0. That's this number here, and then I'm subtracting 87 from that. So this number is precise to 1 place past the decimal. This number is precise to no places past the decimal. So when I do the subtraction, 17 is what I get. 17 is my answer. So that works out pretty well. On occasion, what your calculator gives you is exactly right, and many other occasions you have to do just a little bit of figuring with it, but trust me, this will become second nature. Now, multiplication and division are a little bit different because this is just repetitions of addition or subtraction. What we're doing here is we keep the fewest number of significant figures. Okay, so I'm going to multiply these 3 numbers here together, 1.052 times 12.054 times 0.53. Let me do that one more time, 1.052 times 12.054 times 0.53, off by a factor of 10. And what my calculator gives me is 6.720828, and so on. If you ever find yourself giving like a whole lot of significant figures in an answer, please remember that most chemistry teachers, myself included, tend to go like somewhere between 2 and 4. There are 3 sig figs here, 5 here, 2 here, which means that my answer needs to only have 2 significant figures. So the way that I make this a number with just 2 significant figures is I use this 2 to round the 7, and that rounds down, which means 6.7 is my result. This one right here is a couple of operations, so 2.0035 divided by 3.2 times 1.457, and I get 0.9122186. And again, I've got 1, 2, 3, 4, 5 sig figs, 4 sig figs, 3 sig figs. I'm allowed 3 significant figures in my answer. Okay, the 0 is not significant, so 0.912 is what my answer would be. So nothing too challenging here, but the challenges come in when these become mixed operations. So this operation right here, 5.68. So when I do this bit right here, I'm doing subtraction, and then I'm doing division. So 568.99 minus 232.31. This gives me the number 336.68 and 5.3 here in the denominator. Now, these are both precise to 2 places past the decimal, so there's no change needed here. And generally speaking, I wouldn't do any changes or rounding until the very end anyway. So I take that number and I divide it by 5.3, and I get 63.525 or so. I'm allowed 2 significant figures. This rounds this up to 64. Okay, same sort of thing here. 2.87 times 10 to the 6th divided by 48.533. And this result here is 59135.02. And so on in my calculator. I'm allowed 1, 2, 3 significant figures here. So these 3 are what I'm allowed to keep, but I'm not going to round this yet because I'm not done. This isn't my final answer. To this number, I'm going to add 144.99. And I get 59280.01 and so on. So what am I actually allowed to keep? Well, this goes 2 places past the decimal, but I'm really only precise to the hundreds place right here. So I'm only allowed to keep 2 right here, which means I have to use all the other numbers to round this one. And this would be 593. And I don't just drop these numbers. They don't become, absent. They get rounded. So if you think about this, 280 right here is close to 300. So that's how that number would end up being rounded. So what you want to make sure you do is you complete all of your math and round at the end. Okay, so with that in mind, you're going to want to make sure that all the math that you do from this point forward includes significant figures. So good luck.